How cool is that? Can I get a copy of that video, please? That's amazing. Right, cool, thanks for the intro. This is a pretty huge talk, so I'm not going to spend too long on more introductory stuff. More than you ever wanted to know about resource hints. And I promise you, this talk is definitely more than you wanted to know about resource hints. It's going to be a web performance focused talk. My thing is web performance. This is a shorter version of the talk, so if you want to see the full slides, this URL here has the full sort of 45-minute version of the talk. Grab a quick picture of that. I've kind of abridged today's talk to try and fit it into a little shorter time. My name's Harry, so I had a quick intro. I won't go over it too much, but I'm from the north of England, a place called Leeds. It's a little bit like London, but about 10 times nicer. But it also explains my slightly weird accent, so do forgive me. I don't have like traditional Queen's English. But I'm a performance engineer, a consultant performance engineer, and it is my job to help clients similar to these just have faster, more reliable experiences. There's a lot of different types of company on this slide. And they've all got different budgets, different timescales, different requirements, different problems, and they've all got problems. And it's my job to kind of help them identify what's going wrong and make their websites faster, and that could take any number of different formats. What I wanted to do with this talk, though, is pick out the single, I would say, simplest or easiest thing we could possibly implement to help speed up a website, and just distill it into a 30-minute talk of effective and quick and very, very cheap and easy things that we can do to help web performance. If you see a slide that looks like this, it's going to be a pro tip or a short summary or something kind of memorable that you just need to be aware of. If you see a slide like this, what this will be is a caveat or a warning or a bug or something scary, right? Something that may go wrong if you're not careful. And finally, if you see a slide that looks like this, bottom right-hand corner, a little camera icon, this is probably just going to be a snippet of code, a little bit of syntax, where you just might want to take a picture of it so that as I'm talking through the next section, you can refer back to that syntax. I can see a lot of people in the audience fanning themselves. It is warm. These big lights on me as well. I'm going to be sweating soon. Right, so resource hints. Show of hands, who has heard of resource hints? Who's heard of them? Okay, like 10 of us. Who is using resource hints? Like 3 of us. I like that the other 7 were like, I'm reading about them, but I'm not using them. Well, at the end of this talk, you will all use them because you will find out they are devilishly simple, really easy to implement, and very, very effective. So I can guarantee you will all want to use them by the end of this talk. Resource hints are defined, check this out, as these primitives enable the developer to assist the user agent in the decision process of which origins it should connect to and which resources it should fetch and pre-process in order to improve page performance. My God, that is boring. How dull is that? Basically, what it is, single lines of HTML that can dramatically improve the performance of your web applications. And I'm serious, we're dealing with single lines of declarative HTML that simply go in your head tags that help the browser to determine how it could speed up the navigation for your customers, for your users. The syntax will get a little more complicated than this, and we'll start to learn some unusual side effects and some potential bugs. But at the heart of it, we are really dealing with syntax this simple. The full specification is available, of course, on the W3 site. But the whole point of this talk, I guess, is you shouldn't need the spec. What I've done is I've read through all the specs, taken out the most interesting or useful bits. Useful bits. It's nice to write your own reviews, isn't it? I've given you all the useful bits. But the thinking is you shouldn't need a spec after this talk. First bit of a warning then is that these are resource hints. The word hint is very, very significant, I guess. The browser will decide, based on its own heuristics, whether or not, I don't know if I'm going to hear that. I think someone's about to break in through the roof. The browser will use its own heuristics to decide whether or not it would implement or utilize these hints. This makes them very safe to implement. This means that the browser will decide that, given current constraints, perhaps slow devices or bad network conditions, it could choose not to run these things. This means the browser provides you with a safety net, but it also means you can't guarantee that they will work. What we're going to look at is these resource hints in order: DNS prefetch and preconnect. They deal with domains, if you want to visit a third-party domain on your web application. Prefetch and preload deal with fetching files that may be needed really soon, but fetching them a little bit earlier. And finally, prerender offers web developers a way to build entire web pages in the background so that by the time a user visits that page, it's already been downloaded, built, and rendered, and your website now feels completely instant. So start at the beginning. I'll go through prefetch or DNS prefetch rather quickly because it is probably the least effective and, dare I say, most boring one. It's the least effective, least powerful, but it has got the oldest browser support. So if anybody is unlucky enough to deal with older browsers, this may be of use. DNS prefetch will simply resolve the IP address of a given domain ahead of time. Basically, don't wait until the last minute to find out the IP address of a third party. Look it up ahead of time and sort of up front. So this is good when we know our web application is going to request something from a different domain, but we don't necessarily know the exact URL. Google Fonts, for example, or maybe Google Analytics, or Typekit, or Optimizely, or any kind of third party that your web application will load, you can do the DNS resolution ahead of time to speed up that navigation. The syntax is as straightforward as this, declarative in your head tags, DNS prefetch, and this time I'm going to be prefetching youtube.com. Browser support at the time of writing is reasonably good, 81%, but the key thing on this slide is our old friend IE has a lot of green, more green than you're probably used to seeing. So this does mean if you are supporting older browsers, this will be a useful hint for you. Does anybody have to support sort of like IE9 or anything like that? Anyone IE9? Look at this, what a modern room of people. I do a lot of work for British government, and I have to support IE8, which is why I look so haggard and stressed and disheveled all the time. I'm only 15. IE8 did this to me. So if you have to support older browsers, DNS prefetch will be a very useful thing to be aware of. An example straight from my own website. On a certain page, I've got a YouTube video straight in the middle of the page. The browser's going to get to line 155 and all of a sudden find out that, oh my goodness, I need to go to a youtube.com. I don't know where that is. And this is a very inopportune time to do this. If we know that this is going to happen as a developer, we can give the browser an early warning and tell the browser, hey, look, soon you're going to go and visit YouTube. Ahead of time, though, please go and warm up that connection. So when we have a YouTube embed, we have to step through a series of processes to actually download that file. What DNS prefetch will do is deal with the first step in this process, DNS resolution. Simply turning a domain into a sort of computer-friendly IP address. It doesn't take that much time to do this, but the timing can kind of vary. When I was researching this talk, I decided to look up how fast DNS generally is. Common names, so websites that are visited very frequently, perhaps GitHub or Twitter or Trello, they can answer in closer to 80 to 120 milliseconds. Less common names, websites that you don't visit very frequently, that could stray towards 200 to 300 milliseconds. But then the bad news is, if it's a new domain or a very, very uncommon domain, or we need to go across like recursive resolvers, it can be anywhere between 1 and 10 seconds. So the target we're aiming at is anywhere between 80 and 10,000 milliseconds. DNS prefetch will help us solve this. Here's a screenshot from a friend of mine, and it's, as you can see here, in particular, not particularly effective. But this little bit of green is us looking up the IP address for a domain before we actually need the file. And that's just caused by putting a few lines of HTML in the head tags. Yeah, if you've got IE9 support, or you need to worry about IE9 support, DNS prefetch is implemented as prefetch in IE9. So basically what's going to happen is, well, we'll come back to this later. It gets more important when you try and use prefetch, which will behave wrong in IE9. Basically, IE9 and all other browsers decide to call two things the complete opposite name as each other, which is a very IE thing to do, I believe. Anyway, so DNS prefetch, probably the least impressive one. We're just looking up domain names, right? Not that impressive. With newer browsers, we can use something called preconnect, and preconnect is far more powerful. Anybody who was in my workshop yesterday learned, probably again, way more than they wanted to know, about the sheer cost of opening connections. Opening connections to new domains can be very, very expensive, especially on mobile. So what we can do is we can pre-connect any important third parties. So we'll do the IP address stuff again, but this time we will also open a TCP connection and negotiate TLS to make it secure. This can save us hundreds and hundreds of milliseconds. This is also good when you know the domain, but not necessarily the URL that you're going to need. Syntax, very declarative, goes in your head tags, but this time rel equals preconnect, and I'm preconnecting Google Fonts. Google Fonts is a very commonly used third party, but unfortunately the CSS is going to block rendering. So if it takes, say, 250 milliseconds to just connect to that domain, you're going to add a quarter of a second of a delay before a user can see any content whatsoever. This is a really good candidate for pre-connection. Browser support is actually better than DNS prefetch at 84%, but what you'll notice is our old friend IE, no green at all. This is going to do the next two bits. So DNS prefetch did the DNS resolution. This will also do DNS resolution and these two bits here as well, TCP handshake and TLS negotiation. This is basically opening connections to different domains, and it can get really, really expensive. Here is the simple method, here is the process of just connecting to one domain. We have to go back and forth from the server, the computer to the server, computer server, over and over again, just to open a connection. The numbers we're seeing on this screen are very optimistic as well. These 28 millisecond round trip, that's basically the speed of light between London and New York. The web doesn't travel at the speed of light, it travels at a fraction of that. So the cost of opening connections can easily reach hundreds of milliseconds. What we can see on the screen here is actually, I think, 168 milliseconds of delays. Now, 168 milliseconds doesn't sound like a lot of time, but I worked with a client in the UK who are called Trainline. They determined that if they could speed their website up by just 300 milliseconds, they would make an extra £8.1 million a year. So 168 milliseconds is just over 4 mil to them. By the way, pro tip, when you're working for a client, never tell them what you actually do, just tell them the results of what you did for them, because I couldn't submit an invoice saying, I put some HTML in your head tags. But the real-world benefit of doing this can be tremendous. If you're working for particularly e-commerce, it's going to be quite an interesting optimization, an easy optimization. This is my site years ago before pre-connect ever existed, before it was a thing. And then, I don't know, maybe several months later, whatever it was, I implemented pre-connect. All of a sudden, you can see these connections that I'm making are completely divorced from the file download. We're saving hundreds of milliseconds here. For the sake of a few lines of HTML in the head tags, this could be worth hundreds of thousands of euro a year to the right companies. If you do want to support older browsers, what you can do is do your pre-connect for your new browsers and fall back to DNS prefetch. And the nicest way of doing this is simply loading the rel attribute with 2 values. This is completely valid HTML. This is a nice sort of terse way of doing it. It's a nice, clean, quick, and easy way of getting browser support for old and new. The bad news is this just flat out doesn't work in Safari. So if you want to support Safari, which we probably do, you have to do the slightly, it is a short-term bug, by the way. The bug has been opened. It's a short-term thing. If you do want to support WebKit, which you probably do, you have to resort to this. It's a little bit ugly. It's a little bit verbose, a little bit redundant. But the key thing here is put your pre-connects first. Modern browsers will do a pre-connect, and then when they get to the next line, they're like, well, I've already done a pre-connect. I don't need to do the DNS. I can skip over it. So if you want to support older browsers, this is the order you need to write your resource hint in. Ooh, okay, some words of warning. Now, the browser will be smart, and the browser will try and hold your hand, and the browser will try and make sure that none of this stuff is done wastefully, but it's very important to be judicious with pre-connect. Only warm up third parties that are important to the page. So things like Google Fonts, or Typekit, or Optimizely, or I don't know, even Google Analytics. I would say Google Analytics is probably a good third party. Bad third parties, stuff like Facebook tracking pixels and all that nasty stuff, don't pre-connect those, right? Let the browser find those in its own time. But important or frequently used third parties, those are a good candidate for pre-connection. Don't warm up your third parties. If you link to a third-party provider and then they link to their own third parties, we call them fourth, fifth, and sixth parties. Don't warm those up. Only focus on your own stuff. Audit your own pages and look for critical, early, important domains and warm those up. Definitely don't have time to go into it during this talk. Plus also, if these are being recorded, I probably shouldn't say it anyway. But there's a really weird, messed up, disgusting, sort of bizarre, you probably won't even believe it when I tell you, behavior in Chrome. That means Chrome can only do 6 DNS queries at once anyway. Buy me a Shlivovica and I'll tell you exactly why. I'll tell you what happens. Bad news. It just stopped working in Firefox recently. It's a regression. It will come back, I'm sure. But Firefox just pre-connect just stopped working. So if you're debugging in sort of Firefox 66, I believe, you're going to see that pre-connect just does not work. It'll be fixed. There is a bug open for it. It's a simple regression, so re-enabling it should be quite trivial. But if you are in that bizarre scenario of you happen to be testing in Firefox 66, it will be broken. Whew, right, next one. Prefetch. Prefetch is where things, for me, get a little more interesting. We can be a little more intelligent about how we design and build web applications. The first two, they merely dealt with linking to different domains. What prefetch will allow us to do is grab a file that's needed for subsequent navigation. Now, spec writers would make really good lawyers because they're really sneaky about how they word things. What this realistically means is download a file that's needed on the next page. The reason we don't use the word next is because it might be needed in 3 pages' time. So we use the word subsequent. And then the reason we don't use page is because single-page apps don't have pages, so it's referred to as a navigation. What this means is this has to work with single-page apps. So it's a nice kind of side effect that because of how the spec was written, it has to be honored in different contexts, including JavaScript single-page applications. So in this example, again, goes in your head tags. What I'm doing is I'm grabbing a video player JavaScript file that will be downloaded ready for use on the next page. It's not needed on this page. It's going to be needed soon. So the example is, browser support 82%, and definitely start using it. My go-to example would be this. Imagine we work for YouTube, right? Pretty cool job. We work for YouTube, and it's our job to build the search results page. We've got a 95% certainty that a user is going to click on one of these thumbnails and go to the next page and watch a video. Therefore, what we could do is we could be smart and say, well, this JavaScript file is needed to power the video player. Let's not wait until the video player page to download it. We'll download it from the search results page. We'll download the video player early, so by the time the user gets to this page, the JavaScript is already there, and it just needs executing. And that will do all the fetches for the video and relevant content. So that means on your search results.html page, all we're going to do is point to this video player. The video player will be downloaded, stored in browser cache, ready to be invoked on the next page. So all it's going to do is drop this file in your browser cache. This makes it very, very safe. The key thing here is this will download the file, but it will not run it. In fact, the spec says the user agent should not apply pre-processing and must not automatically apply it to the current context. What this basically means is prefetch is just an inert downloader. It's just a download mechanism. The search results page is what will download the JS, but whatever you use to invoke the script is what will execute it. So again, these are very, very safe to use. Basically, you're just going to drop it into your browser cache. Then the next page comes along, and instead of going to the network and trying to download a video player file, it's like, oh, sweet, it's already in my browser cache. Much, much quicker. Some weird things, though. Prefetch will not work if you've told the browser it can't cache a file, obviously, so it will refuse to do that. If certain conditions are met, the file gets revalidated. But the weird bit for me, very arbitrary, apparently if the file ends up getting older than 5 minutes, it gets revalidated. I don't know how that was decided or why, but apparently if a file is more than 5 minutes old, prefetch will be less effective. So you need to basically decide, is the user likely to get to that page within the next 5 minutes? Probably, hopefully, they will do. But if not, maybe don't prefetch the files. More good news, prefetch is fetch with the lowest possible priority. What this means is, if we're downloading a file that might be needed on a next page, the browser will not interrupt the current page performance in order to fulfill this request. Again, it's made very, very safe. A question I had for myself was, if I'm on page A, and page A starts downloading a huge, huge file, what if I leave that page before the prefetch finishes? Will the browser cancel the download and resume it on the next page, leading to wasted bandwidth? Will the browser cancel the download and never resume it, potentially meaning slower experiences? Or will the browser continue to download the prefetch in the background, no matter which page I navigate to? The answer is, the browser's pretty smart. The browser will persist the prefetch asynchronously, even if I leave the page that invoked it. What this means is, no double downloads, no canceled downloads, no wasted bandwidth. Again, this makes prefetch very, very safe. Oh yeah, this is the bad news, right? So the IE9 thing I was talking about, it was implemented as the opposite way around in IE9. So if you're trying to use prefetch in IE9 to maybe grab jQuery, all that's going to happen is IE9 will conduct a DNS prefetch. So this will not work at all in IE9, but it looks like I'm the only person in this entire room who has to worry about this. Right, the next one, preload. And preload is where things, for me, start to get a little more controversial, because I do have some really bad news about this one. What I'm going to do is I'm going to build you up and get you excited, then dash all your dreams. I hope your dreams aren't actually as boring as that. I dream about this kind of stuff, but I'm presuming you don't. Preload, I kind of lied to you a little bit. Preload isn't actually a resource hint anymore. Preload was the first of these hints that was actually made mandatory. So the browser isn't going to treat this as a hint. The browser treats this now as an instruction, which means there is a new specification for preload. It was pulled out of the resource hint spec, and it's been specified completely separately. This is a mandatory fetch for a file needed later in the current navigation. What this means is basically, is the page soon going to request a file, but we can tell it a bit sooner? Is the file going to be late discovered, but we could tell the browser ahead of time, hey, look, trust me, you will need a web font very soon. What this will do is it will help us surface these late discovered resources, and I'll come back to what I mean by this in a couple of slides, but this is a way to help developers, or rather a way for developers to help the browser make decisions about how to prioritize the current page's assets. Syntax is looking sort of familiar, but we'll notice now we've got a second line, this second suite of options, a load of new attributes, and I'll talk through each of those attributes in turn. Some of them are mandatory, some of them are optional, but they are all very, very important. Browser support, 78%, so definitely one to consider using. But there are some interesting things that are going to come up with preload. We'll learn in a second. So what is a late discovered resource? The way we load web pages is actually really, really, really inefficient. Like, it's just slow by design. Preload helps us kind of sidestep some of these issues. If you take, for example, a web font we have to download some HTML, which then will download some CSS, which will then download a font. This font at the very end of the waterfall is what we would call a late discovered resource. We're finding this asset way later than we would like. Background images say the exact same thing, right? If your background image is enormous, but it's hidden away in a CSS file, it's going to take quite a long time before the browser finds it. If anybody's building a single-page JavaScript client-rendered application, I've got some bad news for you. Client-rendered JavaScript applications are slow by default because everything becomes a late discovered resource. You've got to download your HTML, which then downloads app.js and vendors.js. That'll then build the VDOM, and then the VDOM might inject some styles. And as styles ask for a font, we're getting a very, very, very slow kind of behavior here, just by virtue of how the system works. However, taking the single-page app example, if we just use preload, we can tell the browser to find those sub-resources way, way sooner. Putting this in our HTML, so our app.js is being requested, but also preload a style sheet and preload this web font, that waterfall, instead of being completely serialized, stacks up like this, way faster. So it's a declarative fetch for files that normally would be found really late, but we can instruct the browser to kind of act ahead of time. It's a really good way of clawing back those lost seconds, or milliseconds, hopefully, just by using a few lines of HTML. OK, the as attribute, interestingly, used to be optional. It is now mandatory. What the as attribute will do is it will tell the browser how to deal with this download. The annoying thing about it being made mandatory is that loads of people implemented preload without the as attribute. Then those sites are still in production. Then all of a sudden, the browser, or the spec and the vendors said it now is mandatory. It means loads of people have got preloads in production that just aren't working anymore. So that, for me, is quite annoying, but we can't really do much about that. The as attribute will be from a preset list that's defined by the spec. So is it going to be a font or a document, a style sheet, or a JavaScript file? And what this helps us do is to set the necessary request headers, set the necessary CSP sort of rules, and do sort of prioritization. If you've got a preload for an image and a preload for a CSS file, the browser will get the CSS file first because CSS is more important than images. What you can see here is sort of implemented correctly. The priorities of each of these files was set accurately because of the as attribute being present. Oh yeah, I'm willing to bet at least a couple of you in this room fancy yourselves as hackers. And you've probably already thought what I'm about to say. Well, hang on, if we've got an as attribute, and we can say download this file as a script or this file as an image, if it's meant to look like this, can I trick the browser and maybe do this instead? The answer is no, you definitely can't. Or rather, you can, but it will blow up in your face. I sort of tried this out for this talk to see what happens. Makes things way worse. We get double downloads. Everything's requested wrong. We tried to download an image as a JavaScript file as a CSS file. The browser can't deal with that. It just kind of gives you some console errors, and then what you're going to end up having is double downloads. So don't try this. However, if you want to achieve this, a little bit of bonus material for you. In fact, take a picture of this slide. there's a new specification that's on the horizon called priority hints. Priority hints is going to be really, really powerful and also incredibly simple. It allows us to actually interject and tell the browser how to reprioritize assets separate to what its own sort of algorithm would do. It's as simple as this. We get an importance attribute. Importance equals high, importance equals low. We can tell the browser to treat files differently depending on how we view them. The type attribute is optional, completely optional, but it helps out in a weird scenario where a browser may support preload, but may not support the file type we are preloading. Good example is Safari. Safari supports preload, but doesn't support WebP. So by using the type attribute, we can tell Safari, look, just don't bother downloading this. I know you could download this file, but please don't bother. Next, we have the cross-origin attribute. This tells us how to deal with credentialed requests and whether it needs fetching over an anonymous connection or not. Does anybody understand cross-origin and cause quite well? Anybody got a good understanding of cross-origin? There's one confident guy in the middle. I know nothing about it. And every time I try to read about it, I'm just like, oh, it doesn't make any sense. So what I do is, and I would advise you do the same, is just keep an eye on console. Console will tell you if things are starting to go wrong. Here I built a page where I got every single thing wrong with each different type of preload, and DevTools really helpfully tells me exactly what mistakes I made. So when you're implementing preload, do keep an eye on console. Here's the time for the bad news, and it is bad news. Preload is amazing. It's meant to make sites way, 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 way faster. I've actually been removing it from client projects, and I've been recommending most people do the same. Preload is very badly broken in Chrome. Chrome over-prioritizes preload requests and actually steals bandwidth from more important assets. Here's a little test case, and what I want you to take note of is the CSS files near the top. They all took around 360 milliseconds on average to download. Render blocking assets, about 360 milliseconds to download. And what you can't see is somewhere like down here, there are a few web fonts. And on this project, we decided to, well, let's bump the web fonts up. Let's preload the web fonts so they arrive sooner. They did arrive sooner, but what you'll notice now is all the CSS files took maybe around, on average, 800 milliseconds to download. Almost twice as slow, right? What happened is the fonts were over-prioritized, they stole bandwidth from the CSS, and this site got about 400 milliseconds slower. I mentioned Trainline, who 0.3 seconds was worth 8 mil to them. If I'd have implemented this for them and made the site 0.4 seconds slower, I probably owe them over 8 mil. Terrifying. So what I've been doing is, unfortunately, regrettably, I've been removing preload from Chrome. It's a temporary sort of breakage, but it is quite severe. So if you're using preload in production, I would recommend immediately checking your stats in Chrome. It's a temporary thing. It will get fixed, but it's not fixed yet. OK, I've not got much time left, so I'm going to try and quickly go through prerender. Prerender is like the final boss. It's the big one. Previously, we looked at downloading simple files or even just warming up IP addresses. Prerender is just massive by comparison. What it will allow you to do is fetch, download, and construct an entire web page in the background without a user ever noticing it, so that by the time they click through to that page, it's already on the machine. It's effectively been rendered in a hidden tab, and it makes web experiences feel genuinely instant. Download and build entire web pages in the background. Sort of. It's a long, complicated story. Prerender was really badly implemented, really badly implemented. They got a lot of things wrong, security things, performance things. So it's had a very interesting sort of little life. The syntax is among the simplest we've seen. Prerender and href, no other attributes are needed. And what we're doing here is saying, well, if a user is going to use the app, they have to log in first, so we might as well pre-render the login screen from the home page, for example. Browser support is 71%, and what I find really interesting here is pre-render was so badly screwed up that the IE team never bothered to port it across to Edge. They were like, nope, let's leave that one to die. The use case here is, go back to the video player example, the YouTube example. Instead of just downloading the JavaScript file for the video player, why don't we just download the entire video page, right? Start downloading that in the background, so that by the time a user clicks on one of those thumbnails, the site or the page is built. It's there. It's good to go. Instant navigation. But yeah, no, it is definitely dead. They killed it. Oh yeah, the problems with it, I'll try and quickly go through these, because the problems are actually huge. You tell a developer they can pre-render some pages, they're going to pre-render their entire site. If you've ever restarted Chrome and it's had 50 tabs open, and your machine goes so slowly you have to go make a coffee just to pass the time, imagine doing that, 25 pre-renders in your head tags. What that's also going to do is it's going to increase the bandwidth that you spend as a company serving those assets, and hopefully not, but potentially the cost for the user. If they're on a pay-as-you-go data plan, they're downloading 25 times more pages than they should be. That's terrible. Because it's rendering the page, all of a sudden, your Google Analytics traffic goes up. Oh, wow, we had way more traffic last month. No, you didn't. You just rendered 4 invisible pages per individual page that was visited. But on the flip side, if you're running ads on that site, and your ad impressions go up by 4 times, maybe I'm OK with that one. How do you deal with things like timers or interstitials? How do we deal with things that need user intervention, sort of GDPR banners? If it's in a hidden tab, how do we decide how that gets handled? And the worst one, the security implications are huge. If we visit an insecure website, maybe just like a local restaurant, right, but their site doesn't run over a secure connection, and we're on public Wi-Fi, and somebody man-in-the-middles us, if they injected a malicious pre-render into a page, they basically have complete access to run any page of their choosing in a hidden tab on a user's device. That page could be doing anything. It could be mining cryptocurrency, right? It could be doing stuff way, way worse. So, understandably, having learned all this, they killed it. Pre-render is dead. But it's not, actually. It's not. It came back, resurrected, but it got a different name. Following the pre-render story for me professionally has been so freaking weird. It came back, but now it's called no-state prefetch, which is annoying because all the other names are kind of sexy, like pre-render and prefetch, and this is now no-state prefetch. Sounds very dry, very boring. What they did, though, is pretty smart, actually. In order to preserve backwards compatibility, what Chrome decided to do, Chrome engineers, they kept the same syntax. So you still use the same syntax. So all these websites out there that have pre-renders in their head tags, they don't just stop working. They will still work, but functionally, under the hood, the API is sort of latching onto something called no-state prefetch. The important thing to remember, I guess, is that pre-render won't actually render anything, which makes perfect sense. The way I would see no-state prefetch is I would treat it as a recursive prefetch. So earlier on, we looked at how we could do a prefetch just fetching the videoplayer.js. If we wanted to prefetch more files, we just have to keep adding lines of HTML to the head tags. That means that if we've got 5 files we want to prefetch, head tag gets bigger. 15 files, head tags get bigger. This is a very manual process and not very developer-friendly. So what they decided to do now is treat pre-render as a recursive prefetch, and you basically just point to a page that acts as an entry point, like a shopping list. So now what we'd do is we would say, hey, from page A, pre-render page B. The browser will open page B and just download all of its sub-resources. In a way, you could see your pre-render as a bit like a package.json. You point to an entry point, the browser reads through it, and it looks at all the sub-dependencies of page B, and it will download them for you. The key difference is it will not put this page together. It will not run any code at all. That fixes the performance implications, fixes the security implications, fixes the analytics implications, much, much safer. Pre-render is basically as simple as this. I'm pre-rendering my own homepage here. And what you will see is that these are fetched with the lowest possible priority, just the same as normal prefetch. This means you will never harm the current page performance in order to fulfill your pre-render. Makes it very, very safe to use. What you'll see here is the vertical blue line is the page's load event. What I'm doing is from my little dev site, I'm pre-rendering my homepage. The browser waits until the load event has fired before it fulfills any of these requests. Basically, make sure the first page is fast, then when that's finished, preload the next page, or pre-render the next page. I'm wrapping up now. That was a complete blast through everything. I've gone a little bit over time, but finally, all I want to say is these are really, really interesting and simple things to implement, and you can have a lot of granularity. So audit your sites, audit key pages, and look for maybe predictable user journeys, or look for very commonly used domains. You can design really bespoke strategies for putting these things together. Because they are very safe to do, I would encourage you to experiment. Of course, measure the before and after every time. But all these resource hints are designed to be very, very passive. They're a very, very good way of improving performance. But finally, also, just beware, Google Chrome isn't our friend at the moment. And like I say, if you buy me a drink, I'll tell you exactly why. Thank you very much for your time. I'm going to go and try and cool down somewhere.